This video is about how to use the first derivative to classify the stationary point. We know the stationary point includes local minimum, local maximum, and also stationary inflection point. So for this class, we will use first derivative to classify which one is local maximum, which one is local minimum, or which one is a stationary inflection point. We will use called neighbor value test to decide the stationary point is a local maximum or minimum or stationary inflection point. Here is the steps. You will get the derivative first. Then you set up derivative equal to 0, solve for the zeros or solve for the roots. Then for these roots, suppose it's A, we will do the neighbor value test. We will choose A plus 0, 1 and A minus 0, 1. We just need to check the sign of derivative at A minus 0, 1 and A plus 0, 1. For example, when we have this is a positive, here's a negative. When derivative positive, that means increasing graph, right? And then for f prime of a equal to 0, that means here's 1 point. Then when the derivative of x at a plus 0.1 is negative, that means decreasing graph. Therefore, this point will be maximum. You see here's the maximum. When you do from positive go to 0, then go to negative, this point A is a local maximum. If A minus 0.1, that derivative is negative, then at A plus 0.1, the sign of derivative is positive. You could say the graph will be look like this. This is going down, then go here, then go up, because when derivative is positive, it's an increasing function. Then you could say this is a local minimum point. If this is a positive and both positive, the graph look like, you could say increasing, right? It's increasing. Then it's you get a point, then increasing again. So basically, you could draw the graph like this. And we call this point is a stationary inflection point, SIP. If this is a negative or negative, then you could predict the graph. See, this is going down, then go here, then going down again. So you can sketch the graph like this. You see, this is the point. It's a stationary inflection point. Now let's go to example. You have this function f of x equals this. Then for part 1, you can use a graphing calculator to work that out. For today's lesson, we focus on part 2. For C, show that the derivative equals this. So we just need to figure out the derivative of f of x. When C show that, you can interpret like what is f prime of x. So you will get like f prime of x equals for x to the third power, and you will do like 3 times x squared, then minus 5 over 2 is coefficient, then bring down the 2 for the exponents, then minus 1 to the first power, minus 2 times 1. Just show the work, then you will get the 3x squared minus 5x minus 2. That's how you show the work for C. Now let's go to D. Use the first derivative to find the stationary points. For this D, you will set up 3x squared minus 5x minus 2 equal to 0. For the IB exam, you can use graphing calculator get the solution. But here, I just show you use Ninja X. So you will get the -6, -5. Here's 3, 3. -6, you will get the 1, -6. You add and get -5, so this will be your answer. Then I reduce, get the -2 over 1. Then you will put the x here, So you will get the 3x plus 1 and x minus 2 equal to 0. Your x1 equals -1 over 3 will be -1 over 3. x2 equals 2. If you don't want to show the work like this, you can just say use JDC to find your x1 equals -1 over 3, x2 equals 2. For any equation, you can use graphing calculator to get the zeros. This is the first step. The second step, you need to get the y1 and the y2. So y1, we will substitute into this original function. That will be -1 over 3 third power minus 5 over 2 times -1 over 3 squared minus 2 times -1 over 3. You will get 19 over 54. Then you need to get the y2. We plug into the original function. You will get 2 to the third power minus 5 over 2 squared minus 2 times 2. You will get -6. Therefore, for D, find the stationary points, you will get -1 over 3, 19 over 54. And 2, -6. These 2 points are stationary points. Now let's go to E, classify all the stationary points by the first derivative. We will classify at x equals -1 over 3. So we will draw a table. Here's the f prime of x. Then here's the x value. We will test on -1 over 3. So you do the -1 over 3 plus 0.1. -1 over 3, you minus 0.1. You put into graphing calculator, just check the sign. It's positive or negative. So when you put into graphing calculator, you could say f prime of -1 over 3 minus 0.1, this is a positive. Then here's 0. This is a negative. You can sketch the graph like increasing, then go here. Then going down is decreasing. Therefore, at x equals -1 over 3, it's a local maximum. Then we test at x equals 2. Still, we need to draw this table. We will test on 2 plus 0.1 and 2 minus 0.1. When you put into this derivative function, you could see this is negative sign, here's a positive sign. Then you could see this is a decreasing function. Here's 0, then it's an increasing function. Therefore, this point is a local minimum point.